Okay, in this lesson today, we're going to talk about radicals and exponents. But we're going to talk about the idea of a rational exponent. So I've been throwing this word rational around and irrational. And I thought what we could do is actually just really quickly back up and what do these words mean? Okay, so we have different types of numbers. We have the real numbers as opposed to imaginary numbers, okay, which we'll get to in later math classes. But the real numbers consist of, the first set is the counting or natural numbers. And that would be like 1, 2, 3, ... Okay, that would be the set of counting or natural numbers. That's the most basic set. Then within this, or outside the next set, is the whole numbers. And the whole numbers are 0, 1, 2, 3, ... So I always like to say that 0 is a whole lot of nothing, right? Because it's a whole number. But it's the only difference between the counting. Notice the counting numbers are all contained within the whole numbers. The next set are the integers. And the integers are all of the whole numbers and their opposites. So you would have -2, -1, 0, 1, 2, going from positive to negative infinity. Okay, so that's my little ... Keeps going. And then the next set, which all of these are a member of, are the rationals. Okay, and the rational numbers can all be written as a fraction, a over b, such that b cannot equal 0, right? So we can't divide by 0, but a and b are integers, and you can always make them into fractions. So an example of a rational number would be 1/2, which is equal to 0.5, and we know that's a terminating decimal. What's another example of a rational number that's a repeating decimal? Anyone know a famous repeating decimal? Maybe 1/3, which is 0.3 repeating. So all repeating and terminating, and even, by the way, something like the square root of 25. Why is the square root of 25 considered a natural number? Because it's 5, and 5 is a counting number or a natural number. So these are all very nice and rational. Actually, all of the counting numbers are rational numbers, because even if I took something like 9 and divided it by 3, 9 divides by 3 times. So that's the same thing as 3. The opposite of rational is this crazy little set over here called irrational. Okay, so irrational numbers, the most famous irrational number is, does anyone know? Pi. Pi is approximately 3.14159, ... keeps going on. So that's where we get into the difference between rational and irrational. All rational decimals either end or repeat with a pattern. Pi goes on and on and on for infinity. What are some other examples of irrational numbers? Well, the square root of 35 would be irrational because it's not a perfect square. So if you take the square root of any number that's not a perfect square, even like the square root of 12, which we said simplifies to 2 times radical 3. We were simplifying that last time. So anything that you take the square root of that is not a perfect square is considered irrational. So now we have another topic, which is the idea of a rational exponent. So actually, anytime you hear this word rational, you can think of the root word, which is ratio. A ratio is just a fraction. So if I take the square root of 25, I get what? 5. And we would consider that a rational number because it's a counting number, right? Now, if I if I take the square root of x squared, what do I get? I get x. Now remember when you did this, x to the third power to the second power. Do you remember when you did that in the previous math class? What was the rule for when you take a power to another power? You multiply the exponents. So you get x to the what power? Sixth power. Okay, now if I wanted to take x squared to a certain power that would give me to the first, what would that power have to be? So what number times 2 gives you 1? 2 times what gives you 1? 2 times 1/2. So it turns out that the square root is the same thing as the 1/2 power. Okay? Think about this for a minute. The cube root of x cubed is what? Is x. So x to the third to the what power gives you x to the first? What's this as an exponent? The cube root as an exponent is the 1/3 power. So that means the square root of x is x to the 1/2. The cube root of x is x to the 1/3. The fourth root of x is x to the 1/4. Okay, so it turns out we have what's called a rational exponent. A rational exponent, all that means is that it's an exponent that has a fraction. Okay, and what we're going to see here as we go to this definition, if we go to the definition right here, we have for any real number b and a, or b, and a positive whole number, n is greater than 1, b, the nth root is the same thing as b to the 1/nth power. So we're taking that base and we're using what's called a rational exponent. Okay? If n is even, and this is what we were talking about last time, if n is even, can you take the even root of and b is greater than 0? What kind of numbers are greater than 0? Positive, all positive numbers. So if you have a positive number and you're taking it to the even power, we call this, what would that work out? Yeah, it's going to be, we're going to have a positive answer. If n is even and b is less than 0, meaning b is a negative, so here b is positive, and if b is negative, meaning the base is negative, can you take the even root of a negative? For example, if you took the square root of -2, what would you get? It would be not real. Remember, this is what we were writing the other day. Okay, and then if the nth root is odd, what would this be? B could be anything, right? So the nth root here, b could be, b is positive or negative, depending. Okay, so let's just look at some examples here. So if you're going to write the expression in a radical form and then you want to simplify it. So essentially we want to take it from the rational exponent to, what does the 1/2 power mean? Yeah, so this is the square root of 64. And notice you want to really read the directions carefully because a lot of people here will just switch to, what's the answer going to be? 8. But notice it says write each expression in radical form, that's like that, and then simplify. So you want to do both things. Now here, with this negative, is the negative included in this exponent or not? It's not included. So this is going to be the same thing as negative square root of 49, right? Do you see why the negative is going outside and not inside? It's not part of the exponent because there's no parentheses around it. So what would be your answer here? -7. Excellent. Now here, this is going to be the square root of what? -49. And what happens when we take the square root of a negative? Yeah, it's not real. Okay. What about this one? You have the fraction exponent here. How would you, what are you writing this as when it's to the 1/3 power? The 1/3 power is the same thing as the cube root. So you have the cube root of 8 over 27. What's the cube root of 8? 2. What's the cube root of 27? 3. So those are both perfect cubes. What are we finding here? If we're going to write this one in radical form, where would you put the negative? On the outside. How come on the outside? It's not included. And what index do we have? The 4th root of 16. Do you know what the 4th root of 16 is after all that practice today? It's 2. So this is going to be -2. And then here, what's this one going to be? The 4th root of -16. And what would you say about that? Not real. Okay, I'm going to pause this for you to take time to practice, and then we'll come back to do the next part.